Right, at this moment, guys, I'm giving you some kind of extras here. This is not strictly about functions, which is the major topic we're discussing now, but it's about radicals. Radicals, in this case, they're related to exponents and all those things. When I'm talking about radicals, it's when we use this kind of a sign, which you call it a radical sign. I think this is a radical, we call this a radical sign. And normally there's a number there or nothing. If there's nothing there, we assume the number which is there invisible is 2. And then you get a square root of 2, of x. Now, what is important, I think I discussed this briefly when we're talking about exponents. When you talk of a square root of a number, I don't know, maybe I'm funny. I always want people to be able to tell me what does it mean to you? Square root of x. Can you talk that thing back to yourself and say, it says this to me? When I'm talking about square root of x, I'm talking about a number. What type of a number? Can you say that to yourself? What type of a number are you talking about? This is math. This is math. Can you come and sit here? When you're talking about the square root of x, what kind of a number are you talking about? Nah, that is not interesting to me. No, when I'm talking about the square root of x, I'm talking about a number which I'm going to multiply by itself and give me x. No. Listen to me carefully. When I write this thing, this is symbols are very funny things. They can have any shape, but the most important thing is the meaning of the symbol, not the shape and how it looks like, not the color in which it's written. When I write a symbol like this, what should get to me, I see, but I must remain with the meaning. What's the meaning of this? I'm talking about the square root of x. But what really am I talking about? I'm talking about a number which when I multiply it by itself, I'll get x. That's the meaning of that thing. All together. So if this thing multiplied by itself, I'm going to get x, which means square root of x multiplied by square root of x, I'm going to get x. All together. And then notice how I've written my multiplication sign there. My multiplication sign is a cross. My x is this kind of x. Can I appeal to you? Can we all use this type of x in mathematics? Not use this x. This is a multiplication sign and this is x. Maybe let me do it nicely. Let me do it nicely, exactly the way you must do it. If you write that as x in an expression, a function, whatever, I'm going to subtract a mark. If you write this as x in a function or an expression, algebraic expression, I'm going to subtract a mark. Because now if you write this as x, now what is this? Is this x times x or is times? I hope you understand my meaning, my emphasis here. What I'm saying here. You cannot present things to put double meanings. Altogether, it mustn't be ambiguous, it must be very clear. So let's agree. We're going to write our x variable this way and write our multiplication sign that way. So this is times. What? I don't know. Okay, then let's come back to this thing. Square root of x is a number which when I multiply by itself I'll get x. But x as it is there, can you see that that x is x to the power 1? Yes or no? But do you agree with me that this is x to the power half multiplied by x to the power half? So what does it mean? It means x to the power half. If I multiply x to the power half by x to the power half, I actually get x. What does it mean? It means x to the power half is the square root of x. So you can say here, therefore, x to the power half is the square root of x. So this is a square root expressed using a radical sign. This is a square root expressed using a rational exponent. Are we together, guys? Okay, that's that. So the other thing which is important here, which I wanted to actually talk about this radical sign, is that now you must understand now if I'm having n here and I'm having x here, which means here I've got x to the power 1 over n. Now if I take now this x to the power 1 over n, look at what I'm saying. I'm saying x to the power 1 over n, which you can say nth root of x, and I elevate it to power m. This thing inside here is x to the power 1 over n, elevated to power m. Then this is x to the power m over n. So now you must understand now if I've got an exponent like this one, so there's a radical operation, there's a radical sign, and there's also a power m involved. Do you understand that? And you must check here, where from here I can still write this thing as, remember, a times b is equal to b times a. That's a property of numbers, isn't it? That's a known property of numbers, isn't it? Commutativity. Multiplication is commutative. So now I can write this thing now as x to the power m to the power 1 over n. I just used this. Then what does this mean? This means nth root of what? Of x to the power m. Now we compare these two things now. This together with that, they equal. So these two are equal, isn't it? You see that? But what are they saying? It says, if I've got a rational exponent, it's the same thing, whether I start by elevating the base to power m, then calculating the root, or calculating the root, then elevating to the power m. And that all that comes from here. Am I making sense? Am I making sense? Can you understand what I'm talking about there on the board? My sister, are you there? Okay. So now, I can give you now an expression which says, maybe let's say 8 to the power 3, sorry, no. Let's just correct that. To the power what am I doing here? To the power 2 over 3. What number is that? Given what you've got there. Can you tell me? Calculate it. You follow what exactly what I've discussed in this line here. Can you give me this value of this number? It's 8 to the power 2 over 3. Can you please give me the value? Just work it out. First of all, push the pen against the paper and tell me what the value is. What's the answer? Somebody said 2. Don't say the answer before you push the pen. Are you sure it's 4? Let's see. What is this thing saying? It's saying cube root of 8 to the power 2. Cube root of 8 is the number which you can multiply 3 times as the same factor to get 8. Do you hear how I'm reading this thing to myself? Cube root of 8 is that number which I'll multiply 3 times by itself to give me 8. And that such number is 2. That is in brackets. And at 2. That's the power. Then that's what? That's 4. I would like you to do the other way around. Elevate 8 to power 2. What's that? 8 to power 2. Is it 64? Is it? Then you take 64, you break it down and see to what base you can write 64. To the power what? To the, no, sorry. What you can multiply 3 times to get 64. So I'm trying to say you then have to find out which number can multiply 3 times by itself to get 64, which is the root. 4, isn't it? So it's the same thing. Altogether, I hope that is making sense there. So expect yourself, you'll be expected to simplify expressions with this kind of combinations, or whatever you want to call it. Right, questions? Are you sure that you're fine? Don't have questions? Okay, let's move on then. And now I want to talk about something like this. Let's say you've got square root of 8. You are requested to simplify this thing and find another way basically to express exactly the same thing. One of the ways I can do this is to write this thing, express it as the square root of 2. Express this number in terms of square root of 2. Check what's going to happen. 8, yesterday it was 4 times 2. Yes or no? And also yesterday we know that x times y to the power a, whether a is rational or not rational, or just an integer, a whole number, whatever, this will be x to the power a, y to the power a. But the radical sign is an exponent, isn't it? Yes or no? So which means this is going to give us what? Square root of 2 times square root of 4. Altogether. Then this is going to be 2. Then we got 2 square root of 2. So I've got the answer expressed in the way I wanted, in terms of the square root of 2. Is it? Okay. Let's see. I'm writing this. Sorry. No. And say simplify. I want you to simplify that and write it with using one radical sign. Can you simplify that? Huh? Right. Can I talk to me? What should I write there? That lady. Yes, you. What's your name? Misoli. Tell me, Misoli. What should I write here? Please show the working. I want to see the steps. First of all, what should I write here? Square root of what? 4 times 2 plus square root of 2. Okay? Then 2 square root of 2 plus square root of 2 equals to 3 square root of 2. Good. That's fine. All together. Anyone has got a complaint? Anyone wants to something clarified? Okay. Now, you'll do this at home. I encourage you to do this at home. If it doesn't work out, then blame me. I'm just using square root of 2 here, but if you use square root of 3, square root of 5 is not a problem. What I want to explain is exactly the same thing. Now, let's come back again to properties of numbers. 1 times a number, and 1 is a number, is equals to a times 1 is equals to what? What is equal to? A. Now, remember, a number like square root of 2, we call it an irrational number. Yes or no? Now, if 2 is irrational, 2 plus 1 is still irrational. So this fraction is a fraction with an irrational denominator. All together? Okay. So sometimes we'll be expected to rewrite this function, exactly the same function, as a number, the same number, but with a rational denominator. Instead of irrational, you write it a rational denominator. The trick is, how do we do that? We need to know this. First, we need to know this. Secondly, we need to know that a over a is equals to 1. Thirdly, another tool which we need to have, we need to remember that a squared minus b squared is equals to a. Tell me. A squared minus b squared is equal to a. Factorization. Not remembered 2 months after writing exam. Yes or no? Okay. Listen guys, these are the tools I need to get a rational denominator here. If you overlook any one of them, then you're not going to be able to get a rational denominator here. So what I'm going to use. In addition to this, I want to introduce you to another concept which says, if I got a number like a radical of a, I've got another number which is 1 minus radical of a. I call those conjugates. The two are conjugates. One is the conjugate of the other. All together. Now listen. If I've got this irrational denominator here, I want to change the denominator to a rational denominator. I must call upon the conjugate. I must remember this. I must remember that. So what I'm going to do here, I'm going to say this number is equal to 1 over 1 plus radical of 2 times 1 minus 2, radical of 2, square root of 2, 1 minus that. The only reason that what this equality holds is because of what you've got there and there. Then we apply the numerator is going to be the same, 1 minus radical 2. Then we come to this a squared minus b squared. So it's going to be 1 squared, which is 1, square root of 2 squared, square root of 2 times square root of 2, 2, isn't it? So it's 1 minus 2, which is going to be minus 1. Then you can rewrite this thing as square root of 2 minus 1, and that's all. Now the denominator, what's the denominator here? It's 1, isn't it? And the 1 is rational. Is it true that 1 is a rational number? Okay. Why? Why do you say 1 is a rational number? Give me 1 as a rational number. Give me 1. Write 1 as a rational number. Or you just know that 1 is a rational number. But you can express it. What is it? I've just done it here. There. A over A. That is that. That is 1 is a rational number. A over A. What is A? Any number which is not 0. Are we together, guys? Okay. I think now having this, the exercise involved in these things, go and look at your textbook and see where you can get exercises like this, your comparison exercises, work on exercises like this. We are still going to practice further there. Are there any questions at this moment to clarify? Are you understanding everything? Okay. I think it's our time to stop now. Thank you for listening, and I hope the lecture was worth a while.